Hello world, can you do me a favor? Can you take out your phone and open up your App Store? If you're on an iPhone, this is just going to be called App Store. Apple was a bit on the nose with that one, and this is going to be the single source of truth for you to download and install applications onto your phone, barring maybe if you're a developer or are sideloading apps from a computer, this is the place you're going to get your applications from. Now, if you're on an Android, you most likely have the Google Play Store. Like with the App Store, this is a source of truth for you to download and install applications from that have been pre-approved by Google. But unlike with an iPhone, you have an additional option. You can install directly from your phone additional app stores, which allow you to download and install apps not approved by Google, but nonetheless are there for you to install. And likewise, you can also download and install an individual app directly by installing its APK file. Now, on Linux, the files are different and the app stores are changed, but the general idea is the same. This is how applications are installed on Linux. I'm Ryan, and welcome back to Intro to Hacking with Hack the Box Academy. If you've been watching the previous videos, you know where we're at. We are in Hack the Box Academy. I'm in the Linux Fundamentals module, and we are going to be working on package management. We can see that right down here. That is the section that we are in, package management. Last week we did user management, and if you want to know the answers to your homework from last week, well, first of all, you should go and do them, but stay tuned to the end of the video. We'll be going over user management questions, but for now, let's get started with package management. To start, I should probably mention what package management actually is. Earlier in the video, I was talking about installing applications and software, and you might be wondering how that differs from package management. Well, the short answer is that it doesn't. Packages are any application, software, set of files that you might want to install onto your system, and the process of managing those installed applications, software, and files is called package management. I should also mention the way that package management is done completely changes based off of which distribution the flavor of Linux you're using is based off of. So if you are using a flavor of Linux that is based off of the Debian distribution, for example, the way that you do package management will be entirely different than someone who uses a distribution based off of, say, Arch. And in this video, we are solely going to be talking about forms of package management that are relevant to Debian-based distributions. And this covers most of the flavors of Linux that you're likely to be using. Parrot, Kali, Mint, Ubuntu, and all of its variants. These are all Debian-based distributions, and this video will apply to all of them. So today we're going to be doing something a little bit different than the previous videos. Normally at this point I would have you open up Pwnbox, the Parrot Security in-browser VM workstation provided by Hack the Box Academy, but if you are a free user of Academy, that is, that you have not made any purchases on Academy and you have no plans to, I'm going to suggest that you don't use Pwnbox to follow along with me in this video. Instead, I'm going to suggest that you install Parrot Security on your own VM, such as VMware Player or VirtualBox, because if you are a free user of Academy, you are limited in your internet access with Pwnbox. Free users of Academy can access GitHub, but they can't access the rest of the greater internet. And in this video, since we're going to be dealing with package management and installing packages, if you don't have access to the internet, you're not going to be able to follow along. So you have two options. If you're interested, you could make a purchase on Academy, any purchase at all, and that limit would be lifted, or you could install Parrot Security on your own VM, and I will be uploading a video in parallel to this one that shows you how to do that. So feel free to go and watch that video now and come back. Now, that being said, I am in my own Parrot Security VM and I have Bash open, and we're going to be starting off by talking about the Advanced Packaging Tool, otherwise known as apt, not to be confused with Advanced Persistent Threat. apt is the package manager for Debian-based distributions. It comes installed by default, and we can access it by just typing in apt into the command line. So I'll do that now. We can type apt and we'll hit enter, and we get a description of what it is. apt is a command line package manager that provides commands for searching, managing, and querying information about packages. And then we get a list of the most used commands, and we're going to be going over each of these in this first section of the video. So earlier I talked about how your phone has an app store and you can use that to search for and install applications. And likewise on Windows, you might be familiar with the Microsoft Store, which allows you to download and install applications from a centralized location on Windows. You might not use this. More frequently you would install something via an exe file, but nonetheless this is there. On Linux, you also have centralized locations for you to download and install software from. These are called repositories. And your system is already pre-configured with repositories on it, and these repositories that it comes with with are the repositories maintained by the people who produced the operating system that you're using. So in my case, it would be the parent repositories, which are maintained and run by the parent team. And these repositories have on them software that is configured and packaged for your specific flavor of Linux. So if I were to go ahead and try to install something, my system would go out onto the internet, look at the parent repositories, and see if the thing I'm trying to install exists in those repositories. And if it does, it'll download and install it for me. In this way, instead of having to go out onto the internet and download a file every time I want to install something, I can simply run a command and my system will check the repositories it's configured to know about to see if it can download them from there. So let's see an example of what I'm talking about in action. One thing that I can do is tell my system to update its repositories. I can tell it to go out, check the repositories, and get updated information about what packages are available to my system. So I can do that by typing sudo apt update. If I hit enter, it's going to check the repositories that I have my system configured to know about and see if there are any updates. So it tells me that there are 75 packages that can be upgraded, which means there are 75 packages that could be installed to a newer version. And you can also see each of the repositories that it checked that I have it configured to know about. So it, of course, is checking the default parent repositories. You can see that here with deb.parent.sh, the various default parent repositories with different versions. And then I've also configured my system to know about the Docker repository on docker.com, as well as the Microsoft repository for Debian. So these ones are configured by default with parent because they are the parent repositories. These are the ones that are maintained by the parent team. Great guys. And then these two I've manually added to my system so my system can download packages that are available either from Docker or from Microsoft. Now let's say I wanted to install a package and I wanted to check that it was available. Let's say I wanted to install FFuff, a web fuzzing tool that you use for web application pen testing. I could do apt search FFuff, and this is going to search the repositories that I have available to see if there's a package called FFuff anywhere in them. So I'll do apt search FFuff, and it tells me that there is an FFuff package in the parent repository, and I can install that with sudo apt install FFuff. We're doing sudo because we're installing a package, so we need root privileges to do that. I'm running the apt command. I'm telling it to install something, and then I'm giving it the package name of FFuff. So we'll hit enter, and it goes ahead and it installs FFuff. So now, if I type FFuff into my terminal, I can run FFuff. I have the FFuff tool now installed. Likewise, if I then wanted to remove FFuff from my system, I could do sudo apt remove FFuff, and this is going to uninstall the package. It's going to ask me, do I want to continue this action? I'll type yes, and now it's gone. Those are the three most common commands you'll ever use with apt. Apt update, apt install, and apt remove to update your repositories, install a package, and or remove a package. But let's take a look at the man page for apt and see what else we have to work with. So we'll do man apt, and like with any Linux command, this will give us the manual page for it. We'll hit enter, and we're brought up with the manual. If we scroll down, we can see here is the update command. This updates package information from the repositories. We can run upgrade to the latest version of all packages on the system. We can do full upgrade, which will upgrade everything and remove things if that's also needed to do the full upgrade. Install, reinstall, remove, and purge. Now, we did install and we did remove. Reinstall just uninstalls and reinstalls it in one go. Purge, I didn't talk about. Purge is like remove, but it also deletes any lingering configuration files that might have been left behind. Auto remove is also an interesting command, but to talk about that, we need to talk about dependencies. When you install a package, that package might also rely and depend on other packages. Maybe it imports some functionality from a package, or it needs some command to be available to the system to work. Maybe it needs some library of code. For some reason or another, packages often are dependent on other packages in order for them to function. So when you install a package that is dependent on others, it will install those dependencies for you so that way your package works. But when you uninstall the package, the dependencies are left behind. You have these packages that were installed just to support this one other package, but now that that one's gone, you don't need these dependency packages anymore. Auto remove will automatically remove these sort of orphaned dependency packages that are no longer needed yet still exist on the system. So you could do a sudo apt auto remove to get rid of these. Show gives us information about a given package, including its dependencies, installation and download size, sources that it's available from, as well as a description. And edit sources will allow us to change which repositories are available to our package manager. We can also do this manually, which I will show you in a bit. So where are all of the repositories that my system is configured to know about actually stored? Well, try taking a guess. If you'll think back to the video where we talked about the Linux file structure, you might remember where configuration files are stored. They are stored in the /etc folder. So because we're talking about a configuration file for apt, they are stored in the /etc/apt folder. If we do an ls in this folder, we will see we have a sources.list file as well as a sources.list.d directory. So let's try catting sources.list. Here are two of our available sources. These are two of our parent repository sources. We can also try going into the sources.list.d folder and we type ls, and we can see that I actually have a couple things in here. I have Docker engine list, so maybe we can take a look at that, Docker engine.list, and we can see that I have manually added a source for download.docker.com Linux Debian bullseye stable. So what I've done here is I've actually added Docker's repository for Debian Bullseye, the latest version of Debian, to my system so I can install the latest versions of Docker from Docker's own repositories. If we cat msql release.list, we can see that I've also added a Microsoft repository for Debian 11 Bullseye to my system so I can download packages of software that are available on the Microsoft repository. The reason that these are both Debian Bullseye is because that's the version of Debian that this version of Parrot is based off of. And it's these files that I've just talked about that would be modified if we were to run sudo apt edit sources. We can select an editor when we first run it. I'll just choose nano, and it's going to edit our sources.list. This is our main source file. We can also add ones to that sources.d.list directory in our own files, but this is the main source list for apps to go ahead and find different packages. Now, some of you might have seen the command sudo apt-get and be wondering what the difference between apt-get or say apt-cache is between the apt command. Now, in a nutshell, basically apt is just the more modern version of apt-get and apt-cache. Oftentimes they can be used interchangeably. For example, apt-get install is the exact same thing as doing apt install. In theory, you really should be using apt instead of apt-get, but in practice, I found myself using them interchangeably. Sometimes in the same terminal session, I will type apt-get, and then also in the next line, I'll type apt. It doesn't really matter, but if you're new to this and you're forming habits for the first time, I would form those habits with apt as opposed to apt-get and apt-cache. So what I've just talked about, using apt to pull packages from a repository, is very similar to getting applications from an app store. You can think of the repositories as being app stores in themselves. They are centralized locations for you to download packages from. But I also mentioned on Android that you can install things with an APK file, and you are probably used to installing applications on Windows with a .exe file, and on Mac maybe a .dmg file. So you might be wondering, is there an equivalent of this for a Debian-based operating system? Is there a file you can download and install manually instead of going through a package manager? And the answer to that question is yes. And we can see this by actually going and checking out the parent repository in our browser, which we can do. We can view that repository. So we'll go to https://deb.parent.sh, and this is the parent repository. We're going to go to the parent directory, the pool directory, and then the main directory. So this is the main suite of packages available on the parent repository. These are packages that are free and open source that comply with the Debian standards, and we can go ahead and look through them, and these are ordered alphabetically. So we'll go under W, and we'll search for wfuzz, another web fuzzing tool, and we'll see if we can find it down here. And here it is, right here, wfuzz. You can click on that, and we can see that in this folder, there's a few different files here. There is this tar.exe file, which is a compressed version of the package. This is an archive. Same with this original.tar.gz. This is the original package zipped in a gzip file. Then we have this dsc file, which contains text information about the package. And lastly, we also have this .deb file, which is what I'm interested in here because this is kind of the equivalent of maybe an MSI file on Windows or a .dmg file on Mac. It's a compressed archive file that contains information on how to install the package, and we can use that .deb file to install the package itself. And inside this .deb file will be the application itself, any libraries it needs, any documentation that it has, everything that we need to install the package will be in this .deb file. So we can just go ahead and click on it and download it. And it's going to ask us, do we want to open it up with the gdebi package installer? Now the .deb file is a Debian software package file, and there is a graphical interface that we can use to install it, so we could open that up and it prompts us to install the package. We can view details about it. We can see what files are included in the package. We could install it right now if we wanted to, but I'm actually not going to do it from this graphical interface. I'm going to hold off. We can see that the package was downloaded over here, and I'll just copy this and maybe put it in our downloads folder for now. And we're going to install it via the command line using a tool called Dpkg, which of course stands for Debian package. Now, this is actually what's running behind the scenes when you use apt. Dpkg, dpackage, is being run and is being used to install the Debian file and actually do the installation of the package itself. And we can invoke this manually and directly install this .deb file if we want to. So let's do that. We'll go back to our terminal and we'll cd into our downloads folder because that's where I put the package. We can see that it's right there, and I'll do dpkg -i wfuzz. I'll hit tab so it all completes that version information, and I'll hit enter. And it's going to tell me that I need to be sudo. And that's because in order to install a package, like I said before with apt, you need to have escalated privileges as root because you're altering the system. So we'll do it again. I'll do sudo !!!!, which will rerun the last command that I just ran, but with sudo privileges. And we'll hit enter. And it says that it unpacked the package, it set it up, and it processed everything, and it's good. There are no errors. We installed this package manually. And in fact, if I now run wfuzz, you can see that it's now installed on the system. Now, I wouldn't recommend you do this unless you have to, unless you don't have a way of installing it through apt. It doesn't install dependencies for you, and if the package breaks when installing, it can be kind of a pain. I would generally avoid it, but it is there as an option if you need it. Now, I've talked a lot about the advanced packaging tool, which of course is the package manager used to install packages on Debian, as I've said multiple times throughout this video, but there are also other package managers that you might use even on Debian, and these are usually language-specific package managers that install packages written in a particular programming language. The most common example of this would be pip, the Python package manager that installs Python package manager that installs packages from the PyPy. The Python package manager that installs packages from the Python package manager that installs packages from the PyPy repository hosted by the Python. The Python package manager that installs packages from the PyPy repository hosted by the Python Software Foundation. Okay, so you can use pip to install programs that are written solely in Python, or maybe modules of Python code that you could later import into your own Python code. And we can go ahead and take a look at this right now. We can do sudo pip install, and we'll do crackmap exec. And this is a password spraying program that's very common. We can use this to spray usernames and passwords over a network. So we'll go ahead and install this, and it'll enter my password. And it says, okay, it's installed. So we'll do CME, and we can see that we have crackmap exec installed. We use the pip package manager to do that. We can also use pip to install the requirements for a Python application. Frequently, if you download a Python project, it will have a requirements.txt file in it, and you could use that file to install all of the dependencies that that project relies on. So I don't have an example up right here, but we would do sudo pip install -r requirements.txt, where requirements.txt was the file that had the requirements in it. Gem is another example of a language-specific package manager. It's the package manager for Ruby, so we could do gem, and we can see that it's right here. And if we wanted to, we could install, say, evilwinrm, which is a Ruby package that allows you to remote into a Windows server that has WinRM open. So we'll do sudo gem install evilwinrm, and it successfully installed evilwinrm. Now we have evilwinrm available to us. And lastly, the last big way to install projects and packages and software onto your system would be to use Git, to clone a GitHub repository. Frequently, you want to grab and install some open source software project someone's worked on because there are a lot of available tools that are on GitHub, and you're going to want to know how to get them from GitHub. So we can use the git command for this. And particularly, we're going to use git clone. So I'll cd into /opt, and I'll sudo su to switch over to a root user because I need to be root to write to this directory. And we're going to clone the shuttle repository, which is a piece of software that can be used to create a transparent proxy server over SSH. It's really useful if you ever want to pivot through a network. It's not actually important that you know what shuttle is for this video. I'm just going to use it as an example of some software we might want to install from a GitHub repository. So we're going to go ahead and copy its URL. We're going to go back over here, and we're going to do git clone. We're going to paste that URL, so https github.com/sshuttle/sshuttle. We're going to enter, and it's going to clone that into a folder. We'll cd into that folder, cd shuttle. Then if we ls, we can see that there is a setup.py file in here. And we're going to do python3 setup.py install. And this is going to install shuttle on our system from the GitHub repository. And we can go ahead and see that, yes, it finished correctly, it installed it, and now if I run shuttle, we can see that it did error because I didn't give it a proper command, but it is now installed. And that is installing from a GitHub repository. And that is it for the package management section of this video. As always, go and read the actual section. This one has a lot of information in it, and it's very much worth the read in addition to watching this video. So now we're going to go back and we're going to do the homework from last week. We're going to answer the questions from the user management section. So I am back in the user management section of the module, and I did spawn up Pwnbox just so we can work on these questions on the same page. And the first question is, which option needs to be set to create a home directory for a new user using the user add command? So let's try just doing user add -- help and seeing if we can get any information. And it looks like there's a couple of commands that you might think are the answer. -d specifies the home directory of the new account, but if we scroll down, we can actually see -m or -- create -home for the long version creates the user's home directory. And the question was, which option needs to be set to create a home directory? So I'm going to try -m, and that is correct. Which option needs to be set to lock a user using the user mod command? It wants the long version of the option. So we'll clear and we'll do user mod -- help, and we'll see if we can find anything about locking. I see unlock right away with -u. That makes me think -l is probably, yep, and it is. -L is the short version to lock the user account, and -- lock is the long version to lock the user account. So we'll try -- lock, and that is correct. And lastly, which option needs to be set to execute a command as a different user using the su command, long version of the option? So we'll clear once more, su -- help, and we'll scroll up, and we can see that -c or -- command is the flag to execute a single command to the shell as a different user. So we'll try -- command, and that is correct. That is the end of last week's homework. We'll mark that section as complete. And now this week's homework is to scroll down, and we can see that EvilWinRM, which we installed using gem, is also available on GitHub. So the homework is to go on to Pwnbox or go into your own VM and install EvilWinRM from the GitHub repository. Don't install it using gem. Go install it from GitHub. See if you can do that. Then once you've done that, go ahead and try the rest of the installation methods for EvilWinRM. That's your homework for this week, and next week we're going to be looking at services and process management as well as working with web services. So we're going to be dealing all with services and processes next week, and I'll see you then. But until then, goodbye world.